Hello everyone, I am Dr. Fawzul Atiq. I am giving some series of lecture for the course Probability and Statistics. In the last lecture, we have discussed the probability mass function of a random variable, right? Basically, probability mass function for a discrete random variable. So in today's class, we'll discuss about the cumulative distribution function, right? What is that? So for a random variable x, the function f defined by fx equal to probability of x less than or equal to x, right? So it is a probability up to the value x, small x, or this x is any real number, right? So this is called the cumulative distribution function, or simply the distribution function of the random variable x. So if you remember, that probability mass function is what? It was that the small p functions mass function was this, which is probability of capital X is equal to X. So probability at the point small x. Whereas the distribution function is probability up to small x. Right? So this is called the cumulative distribution function, or CDF. Now let us see that some of the one of the property of this function CDF. Suppose I have a is less than or equal to b, right? Then we all know that capital X less than or equal to a, it is what? It is some event, right? It is some event of the sample space of the whole sample space. Similarly, X less or equal to b, it is also an event. Now X less or equal to a is already included in the event of X less or equal to b, right? Because the way we have defined the random variable for any real number, if X is less or equal to a, then this is event, this is a subset of X less or equal to b. If you remember, suppose X is a random variable, that is the sum of the two dice it is giving, right? X is the random variable, like we are throwing two dice where X is the sum of the two dice. X is the sum. If you remember this example, then in that rolling of two dice, that problem, X takes which values? They were taking the values are 2, 3, 4 up to the value 12. Now we have two numbers, one is 2, another is 3. 2 is less than or equal to 3, we know. Now X equal to 2 is what? X equal to 2 is a event, but it is which event? It is the probability of the sum is 2. If I say X less or equal to 2, I should mention X less or equal to 2. So probability of the sum, it is which event? We have only one such case, which is 1, 1. Both the dice giving you that 1, 1. Now, what is X less or equal to 3? Now, it is the event that probability of the sum is up to 3. So it is, then what are this event outcomes? It is 1, 1, or it is 1, 2, or it is 2, 1. Correct? So therefore, you can see that X less or equal to 2, which is this one, which is already included in this set, which is X less or equal to 3. Therefore, we have X, whenever we have A is less than or equal to B, X is less or equal to B. Like X less or equal to A is a subset of the event X is less or equal to B. Now this implies that one of the probability property we know, that if A is less or equal to B, like two subset, A is subset of B, then probability of the event A is less than or equal to probability of the event B. Therefore, this is a subset of this. So probability of X less or equal to A is less or equal to probability of X less or equal to B. But it is what? This is the definition of the cumulative distribution function at the point A. This is the cumulative distribution function at the point B. So therefore, what we got, we initially started with A less than or equal to B, and we got if A is less than or equal to f of B. And it means what? It means that fx is a increasing function or it is a non-decreasing function. I hope it is clear. So what we understand from this discussion that the cumulative distribution function is a non-decreasing function. Okay. Now this part we have already discussed the relation between the probability mass function and the cumulative distribution function. We have if A, it is probability up to A, sum of all the random variables up to A, but probability at x equal to x is what? It is the probability mass function. Therefore, x is less than or equal to A. It is the sum of all the probabilities, all such x, right? So this is the like where p function is the probability mass function and fx capital F function is the cumulative distribution function. And then we have got that the summation, this summation, which is this, actually represent the adding up the probabilities from the probability mass function. And this relation shows that the cumulative distribution function is simply the sum of the probability mass function up to the value A. So up to all values of A, you have to take the probability mass function's value. I hope it is clear. So that means if I have probability mass function, I can easily calculate the probability distribution, like distribution function or the cumulative distribution function. Let's see an example. Now look at this example. Suppose x is a discrete random variable and has a probability mass function given by p1 equal to 1 by 4, p2 is this, p3 is this, and p4 equal to that. And p of a equal to 0 for every other values of a. Compute the distribution function of a or the cumulative distribution function of a. That means we have to find the capital F function. Now how we can do this? So from the probability mass function, we can understand that x takes the value. So the solution is x takes the values where it is 1, 2, 3, and 4 at this 4 point. Other point it is 0. Therefore, x takes these values. Now we consider the least value, which is 1 in this case. Then we will see that case by case. Now for the first one, suppose a is any real number which is less than 1. Right? Then what is p of a? If I have a is less than 1, what is small p of a? It is definitely 0 because we have seen that p values are giving some quantity at this values at p. But all other values pa is 0. So a is not one of them because a is less than 1, so p of a must be 0. Therefore, what can I have? I can have that what is capital F of a values. So it is the summation of small p of x where x is up to a. But we do not have any positive values here because x is up to a, all values p of a is 0. Therefore, this value is equal to 0. I hope it is clear. Now, if I have 1 less than or equal to a less than 2. So a is a variable which is lies between 1 and 2, but not at the point 2. In this case, what is fa? So f of a will be again summation of p of x as x is up to a. Now in this case, the point 1 is also included. So other than at the p of 1, all points are 0. P of that function is 0. So point 1 is included. So it is actually p of 1, other values it is 0. But what is p of 1? P of 1 is given as 1 by 4. So if a is this value, if a lies between 1 and 2, we can have that fa is equal to 1 by 4. And in the same way, we can find the other intervals. Suppose if I have a is less, sorry, it should not be a. If I have 2 less than or equal to a less than 3, if a lies between these two values, what will have? So in this case, f of a is equal to, again, summation, the definition, x is up to a, but in this case, point 1 and the point 2, both the values are included because a is lies between 2 and 3, and therefore I can have it is p of 1 plus p of 2. But what is p of 1? It is 1 by 4. And what is p of 2? It is 1 by 2. So if you will see this value, this is equal to, yeah, if you add it up, you will get is 3 by 4. And then the last case, or maybe I'll do it in the next line. Okay. Then if I have 3 less than or equal to a less than 4, we can easily calculate the same way. So in this case, the point up to 3 all are included. So it is small p of 1 plus small p of 2 plus small p of 3. And if you just substitute all these values, 1, 2, and 3 at the point 1, 2, and 3, it is 1 by 4 plus 1 by 2 plus 1 by 8. And this value will become, if you add them up, yes, it is 7 by 8. And finally, we can just see that if a is greater than or equal to 4. This is the last case. In this case, all points are involved up to a. So in this case, f of a is equal to p of 1 plus p of 2 plus p of 3 plus p of 4. That means random variable, whatever value it was taking, it is addition of all of them, and that sum should be definitely 1 by properties. And you can also check, just to add these values, p of 1 plus p of 2 plus p of 3 plus p of 4, you'll get the sum is 1, right? So we finally got the random, like cumulative distribution function as this one, right? So as we discuss, all the value solution are given here, whatever we have discussed. So it is this one. So after all these intervals, this is the fa, this interval, this is fa, and if a greater or equal to 1, this is fa. So the finally, the cumulative distribution function fa equal to this. So which is piecewise defined function, right? Whenever a is less than 1, it is 0. Whenever a is between 1 and 2, it is 1 by 4. Like that, it is defined. So here from this example, we understand that from if for a random variable, if the probability mass function is given, we can calculate the probability distribution function, like cumulative distribution function, right? So this way we can do that. Now we have this distribution function, the cumulative distribution function is a piecewise defined function, right? Now if you just the graph of it, if you check the graph of it, it is like that. Now what is that? So at the point 1 to 2, this value is this much. From 1 to 2, this value is up to this. From 2 to 3, it is this. From 3 to 4, it is this. Because the 7 by 8. And from after 4 onwards, this value is 1. Right? So it is not stopping here. It is going up to that. All values. For all values of A, after 4, it is 1 only. Right? So one more thing also you check from this figure, that this one thing we need to observe here. Now, what is this? What is this height? If you remember that our probability mass function was giving as P of 1 equal to, it was giving us 1 by 4, right? Similarly, P of 2, it was in this question, probability mass function P of 2 is equal to, it is 1 by 2. Probability mass function P of 3 is equal to 1 by 8. And P of 4 equal to, it was given as 1 by 8. And for all other values, it is 0, right? So check this height. What is this height? That from here to here. It is 1 by 4, right? So this is, this height is 1 by 4, which is the probability mass function value at the point 1. And we can easily see that it is f of 1 minus f of some point, maybe f of 0. Because f of 1 is this value, na? F of 1 is this height. This height is f of 1. And f of 0 means it is this height. So f of 1 minus f of 0. Now again you check another thing. So this observation, why I'm discussing, because it is again helpful for another conversion that I will discuss. But let us identify this. Again, look at this height. What about this height? It is, that means what is f of 2 minus f of 1, right? F of 2 at the point 2, it is this value, and f of 1, it is this value. So it is f of 2 height is minus f of 1, which is 3 by 4 minus 1 by 4. And if you do the calculation, it is 2 by 4 and it is actually 1 by 2. But what is this 1 by 2 value? It is P of 2. It gives the probability mass function again. And the same way we can also see that, what about this value? This is f of 3 minus f of 2, right? And this is 7 by 8 minus 3 by 4. And if you calculate, it is giving you 1 by 8, which is actually P of 3, right? At the same way, we can also see that this value is P of 4, which is f of 4 minus f of 3. It gives you small p of 4. So from this discussion, what we understand that if I have the probability distribution function, then we can easily calculate the probability mass function also. Whereas in this example, what we did, it was given that probability mass function was given and we calculate the probability distribution function, right? Whereas this discussion shows that if you have the probability distribution function, the cumulative distribution function, then from this discussion we understand that you can able to get the probability mass function easily by doing this small calculation. I hope it is clear to all of you. We'll solve one example related. Okay, one more thing. Look at this distribution function, this graph of the distribution function, and what we understand that it is actually a step function, right? And if x is a discrete random variable whose possible values are x1, x2, x3, like that, which are related in this way, x1 less than x2 less than x3, then we have the following few observation. The cumulative distribution function CDF is a step function. Yes, that's what we have understood. It is a step function. It is going like that. So this, like this. The function fx remains constant in the interval xi to xi minus 1 up to xi. So yes, it is constant. Na? This value is constant. Again, from 2 to 3, it is constant value. 3 to 4, it is a constant value. At xi, it takes a step or jump of size pxi. Yes, at the point 1, it is a jump. At the point 2, it is again a jump. And how much jump? It is p of 2 for this case. How much jump? It is p of 3. That's what we discussed. How much jump? It is P of 4. How much jump it was in the beginning? It was P of 1. So at each of this point xi, it takes a step or jump P of xi, where Pxi is equal to capital probability of x equal to xi, which is actually the probability mass function. And then the cumulative distribution function appears as a series of horizontal segment with jump at each xi. Yes, that's what we discussed. And the total sum of jumps, it is reaches as 1 whenever x is a large number. Yes, it can goes up to 1, but after onwards it is remains constant. So for all value greater than or equal to 4, this jump is up to 1. Right? So these are few observations for the cumulative distribution function. Now, suppose we have the cumulative distribution function is given, which is f of x function, capital F of x function. This is given. That means in some interval it is given all at the interval values. We have seen that it will be a some piecewise defined function where the pieces are between one random variable to the another, like one random variable values to the another random variable values. Now, if I have such thing, we can able to calculate the probabilities between two values, like P of A less than X less than or equal to B. So it is, we know that probability mass function gives you what is capital F B function. It is summation of small p of x, where x is up to b. Now, it is probability of capital X less than or equal to b. So this part is there, but you do not have to take all the values. You have to take x is greater than a from there onwards. So if you subtract this value, then what will happen? It is actually a less than x less than or equal to b, because up to a onwards all values you have, from a onwards all these values you have subtracted, all the probability mass function value you have subtracted. So it is fb minus f of a. Right? So if you have cumulative distribution function, you can able to calculate the probabilities between some interval. So p of a less than x less or equal to b, it is fb minus fa. Next, if I have to calculate that p of a less or equal to x less than b, so then what is this value? If I just do f of b minus f of a, it is what? It is the summation of all the values, but a x is greater than a, but up to b, and then p of a. But you need to include the a value and you have to discard the b value. So what you will do in this case? So from there, you just do the, like you have to discard the b value, right? So minus probability of b you do, and you have to include the point a from the previous one. So this is plus b of a, right? So this is this value is actually up to uh, this value is p of a less than or equal to x less than, right? So this, not this one, this value is up to that, right? So it is fb minus fa, and then you include, discard the point b and include the point a, probability at the point a. So this is giving you again, if you have the probability distribution function or cumulative distribution function, you can able to get the probability of this interval. Similarly, if I just calculate the probability on this interval, what will happen? So in this case, the value at the point b also you need, probability at the point b also you need, at the point a also you need. So it is simply fb minus fa, but fb minus fa, discard the point a So you just add the probability at the point A. That will give you probability of A less or equal to X less than B. Right? I hope it is clear to all of you. Okay. Now let us do one example. So the cumulative distribution function of a random variable X is given here. So this is the cumulative distribution function. Now find the probability mass function of X. So we have already discussed that if your probability distribution function is given, you can easily calculate the probability mass function from that. So from the picture we discuss. Now therefore, what I understand from this distribution function, the random variable takes which values? The random variable X takes which values? So the solution is X belong to, it is 0, 1, 2 and 3. The random variable takes these values. That's why we have the break now, because we understand from the previous picture that it is a stepwise defined function. So steps are making in which point, wherever random variable taking some values. So therefore the steps are given in 0, 1, 2 and 3. So random variable takes these values 0, 1, 2 and 3. Now we have to find the probability mass function. How to find? So P of 0, small p of 0 is what? The probability mass function. It is, now you understand that it is basically the f function whenever it is less than 0, right? So it is f of 0 minus, for any value, f of minus 1 or minus 2, any values. But f of 0 is what? It is 1 by 2. From the definition, 0, f of 0 at the point 0, it is 1 by 2 minus f of minus 1. Suppose f of minus 1 is what? Because it is less than 0, therefore this value is 0. So it is 0. So we got p of 0 equal to 1 by 2. Then similarly, what is p of 1? It is f of 1 minus f of 0. We discussed this part because it was giving a jump. So what is that f of 1? It is from this given function is 2 by 3 minus f of 0 is 1 by 2. If you calculate, what value will get? You will get 1 by 6. Then what is p of 2? It is f of 2 minus f of 1. And f of 2 is 11 by 12 minus f of 1 is 2 by 3. And if you calculate, again you will get it is 1 by 4. And small p of 3 is equal to what? F of 3 minus f of 1. Sorry, f of 2. And f of 3 is 1 minus f of 2 is 11 by 12, which gives you 1 by 12. So what we got? It is given that the probability cumulative distribution function, it was given, and we calculate the probability mass function, PMF. Clear? Now other questions are very easy. If you have the probability mass function, after that these things are very, very easy. So what is P of x less than 3? So it is up to 3, whatever value you have, that you have to add it up. But at the point 3, it is not included. So I have this probability mass function, this one. Now capital P of x less than 3. How to calculate? It is small p of 0 plus small p of 1 plus small p up to 2. So if you calculate this value, what value will get? 11 by 12. Similarly, the next question was, this is part B, then the part C question was, what is P of x greater than 1 by 2? So we know that the formula for probability mass function, it is 1 minus P of x is less than or equal to 1 by 2. But p of x less or equal to 1 by 2 include only one point, which is 0. So it is 1 minus p of 0, which is 1 minus 1 by 2, and that gives you 1 by 2. Then the next question was the D part. It is probability in some interval. So p of 2 less than x less or equal to 4. Again, we have discussed this part. The point 4 is included, but 2 is not. So it is f of 4 minus f of 2. It is now what is f of 4 minus f of 2? This is given in the question even. F of 4 was 1, f of 2 was 11 by 12. It is 1 by 12. So we have solved all the given question. The questions was given that compute p of x less than 3, compute p of x greater than 2, and compute the probability between the interval. So finally, what we have learned that probability distribution function like this function, whenever it is given, we can able to calculate the probability mass function, and probability mass function is actually at a particular point probability it gives, whereas probability distribution function, it is the probability up to some particular point, right? And one of them can be found from the another function. That means PMF can be found from CDF, or CDF can be found from PMF. Correct? So most of the content of this lecture we have taken from this Seldom Ross books. We'll meet in the next video. Thank you very much.